Okay, Assalamualaikum and good morning, good afternoon to everyone. So now we will learn on the spanning set. So about spanning set, what is spanning set? So spanning set is more likely on the linear combination that we have learned last week. Okay, it almost the same. Okay, so let's go for an example. So we have V1, V2, V3, V4 with the equations. Okay. So it was asked whether the vector V, so this is the V. So whether the V belong to the span, belong to these vectors. Okay. So how to do? Same as about the linear combination that we learned last week. So we need to know the skala. Okay, skala ke, coefficient ke, constant ke. So every vectors, okay, we have its skala. So let's say skala ni I name it A1 for V1. For the skala for V2, I name it A2. So go on A3 and A4. So make it in this form. So if we know the value of A1, if we can get the value for A1, A2, A3 and A4, then we can say that this V belongs to span of V1, V2, V3 and V4. So what to do? Okay, we write down this one back here. We write it down back. Okay. Then the V1, this equation, okay, masuk dalam V1, insert it in this V1. Okay, V2 also from here. V3, ni V3. From here, V4. Ni V4, okay, from here. And then the V, this V from here. Okay. Then we solve this equation. Okay, saya akan kembangkan lah. Okay, saya kembangkan and we see what we get. So we have these equations. Then as I see in these equations, we have t squared and we have t, and also we have here t power of 0. Okay, kalau t power of 0 is equals to 1. So kalau 1 times 2a1 is 2a1 lah, right? So then I just factorize for the t squared. Okay, and then for t, and then for t power of 0. Okay. So after that, after I've got this in this equation, okay. So I make it in the linear system. So this one, okay, t squared for the first row. Okay. This one in the bracket one. So this is what we've put in the first row. So equals to 1. So 1 from this one lah, t squared. Semua yang t squared, put it in the first row. So equals to t squared. The coefficient is 1. So 1 lah. So then the second row for the t. Ni, in the bracket put it here. And then t ni coefficient dia pun 1. So put it here 1. So ni power of 0. So in the bracket put it for the last row. And then the value is 2. Okay. So after we've got the linear system, make it in the augmented matrix form. Okay. So all the equals this one. So let's say it's a B matrix. So put it for the last column. Okay, this one. So put it in the matrix. So 2, this one is 1, this one is 2. So for A2, so this is A2. 1, and then negative 2, then this one is 0. Same here for A3. Ni 5, then negative 5, then 2. Okay, make it in this form. So, if you want to solve it using the linear system, if you want to solve the linear system, so we have a lot of methods. We have the inverse matrix, Cramer's rule, Gauss-Jordan, and then Gauss elimination method. So you can use any of it, just solve it and get the value of the coefficient. Okay, A1, A2, A3, and A4. So here I solve it. Okay, sorry. So here I solve it using the ERO, elementary row operation. Okay, I make it until in the form of RREF. So if we make it in the form of RREF, then I solve it using the Gauss-Jordan elimination method. Okay, sebab apa? Because we have value when the leading one, for the leading one, its column other than the leading one must be 0. So this one is leading one. So other than the leading one, all the value for the column must be 0. So see here, 0, 0. So this one doesn't have the leading one, so it doesn't matter. Okay, then we have the 0 values at the last row. So we have the value 4/5. So this one is 0. Therefore, when we got in this form, okay, then it is inconsistent. When it is inconsistent, then it has no solution. After we got no solution, means that we don't know the value for the A1, A2, A3, and A4. Therefore, what will happen? The V does not belong to the span V1, V2, V3, and V4. Okay?